Okay, in last video we fixed the sensor. It was reading backward. We flipped the formula and it worked. But here's the thing: a sensor, the sensor, just prints number to a screen, as we can see in our laptops. Uh, we can see the number, which is the moisture, the percentage of moisture, and that's not a system. A system is it have a sensor, a process, and output. And here we have our output. And in last video, that's just a thermometer that you can read the temperature from. A real system acts and it makes a decision. When we have sensor and read the dry soil, it does something in the relay. So today we connect the sensor to a relay, and the relay controls a pump. In this case, my pump, this one, it was broken, so I just use a relay. You can see here, and we can see with relay I add an LED that show us the indicator that the pump was works. So when the soil gets dry, like this, the pump turns on, like this one, and we can see at our serial monitor, we can see that the moisture percentage is very low. It means the soil very dry, like that. We can see the notification here, the status here, soil dry. So and when the soil dry, the pump turns on, so soil gets wet enough, and then pump turns off, like this. I have soil here, I have wet soil. So when the wet soil, the sensor read a wet soil, the pump turns off, like this one. We can see the indicator turns on, off, and the relay turns off too. So when we add pump here, we can turn off our pump. No button, no manual input, just the sensor decides the pump should on or off. And let me show you how. Let's start. Okay, here's the first question people ask: why do we need a relay at all? Can we just connect the pump directly to the Arduino pin or the ESP pin, like what I have here? The short answer is no. We can connect directly this the relay components. This is a relay module, and this is the relay components. We can just connect directly this relay to our microcontroller, because it's you'll probably damage your Arduino or your microcontroller. Here's why. Our Arduino pin output is 5 volts. We can measure it using multimeter. We can measure here. Yeah, you can see at the multimeter display, our working voltage is 5 volts and maybe 14 milliamperes maximum. And then a small water pumps, it wants 12 volts like this one, and pulls 200 to 500 milliamperes. So you can run a truck engine on a phone charger like this, that's the example. A relay is a switch, a small electrical signal from the microcontroller, in my case is ESP32, flips a mechanical switch inside here. So when we unplug this one, the relay should make a sound like this. Okay, that is the mechanical switch inside these relay components. That mechanical switch can handle a bigger current that the pump needs. Two separators words, low power words, Arduino signal, which is we get the signal to control this this relay, and high power word pump circuit that the relay control the pump. So the relay here bridge them without letting the high voltage destroy the low power side. Okay, let's continue. Most relay modules have three terminals on the high voltage side. As we can see here, here we have three terminals, which is NC, COM, and NO. You can if I open this jumper, we can see NO, COM, and NC, which is the NO stand for normally open, COM is the common connection, and the NC is normally closed, which is mean normally open is when the relay is off. When the relay is off, the circuit is open. Nothing, the current can flow from COM to the NC, and normally closed here. When the relay is off, the circuit is closed and current flow. That's the difference. From a pump that we should only run when the soil is dry, we use NO, like I connect it before. So when the relay off, the pump should off, and the relay on, the pump should on. As simple as that. If you accidentally use NC, your pumps run constantly and only stop when the relay actives. The wrong terminal, it means pump never stop and your plant drones. I'm telling you this because I've done it. Alright, let's wire this connection. Actually, I was wired for my using like this. So I changed the pin because I just use the pin for the input side. I will remove the jumper for the high voltage side. Okay, this one, and okay, you can see this is my connection, and if we see in our laptops here. I was define the soil pin is connected to pin GPA01 if we use ESP32, and else we use Arduino Uno. For example, we can connect it to analog node, and ADSMX it's common, and relay pin in ESP32 I use pin 12 like this, this one, and in relay pin in Arduino Uno or others board, I using a pin digital 7, and after that below the next code is we have hysteresis threshold, we have constant float variable that the data type is constant float with the minimum threshold for the dry is 30 and the wet threshold is 60. So when the sensor show the value or the moisture percentage is 30 or below 30, the pump should be on, and if it's above 60, the pump should turn off. And then we have the next variable here. We have two variables. It's pump duration. The pump duration here I set to 10 seconds. So when the pump runs for the 10 seconds, the pump will automatically turn off, and the read internal, the sensor read internal is 2 seconds. So the data we get is the interval is 2 seconds. And then we have the Boolean variable here. It's first that we can get the pump status, and then we have millis variable here, pump start time and last read time. And commonly we have set up here pin mode digital write. We set the relay pin or the pump at the startup, it should be low or off. Okay, we have unsigned millis here to count how long the relay or the pump have turned on. Okay, and then we have the soil reading here. We have our magic formula here, and we print it to serial monitor, and then we have the main logic to control our pump. So if the pump isn't running, this is not, you can see this is not gate or not logic. So if the pump running is not, and the moisture percentage is below or less than dry threshold, the digital write, so the relay pin should be on, and the pump running status should change to be true, which is we get the pump status is on, and the pump start time should start and counting the how long the pump was on. and we print the serial print here, pump on, soil dry, and here if else, as if the pump running and the moisture greater than wet threshold, we have to turn off the pump and set the pump status to false, so the pump off and our soil get wet enough as pump running, pumping, and like this. Okay, now we try to upload. Remember to change your board because here I use ESP32 S3 development modules, so I choose this and I connect my USB to USB node, the port node, because I'm using Linux. Please make sure your choice is right, so you can get the error. Okay, we can upload here or Ctrl U. Okay, the upload process was running. We close the serial monitor first, and as you can see at our hardware here, the sensor eye was let in the air, so it simulates the dry soil. Okay, like this, we can see the moisture was very low percentage. It just around 10%, 11%, 10%. Okay, the average is around 10%, 10% and below. So we want to simulate the soil with, I have wet soil here. I try to plug it in the soil, and we can see at our serial monitor here. Okay, the percentage now goes to around 50%, and it's idle. It means our soil condition is very optimal, so the pump was turned off like this one. Okay, and we try to remove the sensor from the soil, and then this relay turns on again, you can see, and we plug it again, and then the soil percentage goes up, and we wait for it. Okay, it's enter the idle status. Okay, so we can see the logic here. So in the next video, maybe I will add RTC module and a schedule, so the system won't just react to dry soil. It will water at specific time, so our system will be have schedule time every day and automatically. If this was useful, subscribe and see you in the next video.